So hello friends, in this video we are going to discuss about various magnetic materials which are being used in transformer core. So as shown in BH curve, B here stands for magnetic flux density, and here H stands for field magnetic flux strength or intensity. Now here this H can be given as Ni over L. So it means, let's say if you have core, and if you are, let's say, taking n number of turns here and some I current is flowing through this core, and this L is the magnetic path length. So if you sum up everything, this will be L. So this H can be given as Ni over L. So if you make number of turns fixed, and once you choose a core of specific length, then one thing which will be vary is the current. Now here if you increase the current, your field strength will increase. Now based on the field strength, your flux in the core also will increase. Now based on the different field density versus the field strength, there will be different materials. If you use for the core for the transformer, then it will be having different shapes of BH curve. Now firstly is the cast iron. So that is one of the magnetic material which can be used for the transformer core. Second is cast steel, then aluminum steel, then silicon steel, and this is cold rolled grain oriented silicon steel. So this CR, in short, it is also known as a CRGO material. So this CRGO is material is having highest flux density curve as compared to all the other magnetic material, and this CRGO material is basically derived from the silicon steel. How it is derived we will discuss in this video later on. Now here it is important to understand that why this flux density if more in the transformer core, then how it will be beneficial. So as you know that flux density B is can be given as flux upon area. Okay, now area will be based on the specific flux in the core divided by flux density. Now if you are selecting a core material which can offer you a larger flux density, then with the same amount of power rating for your transformer, you may have a lower size core. So if core size decreases, then your cost also will decrease, then also weight of the transformer also will be reduced. So that's why it is always preferred to choose higher flux density core material in which CRGO and silicon steel majorly falls. Later on, in from the cost perspective, people may also use aluminum steel, then cast steel, cast iron, but based among all the given material, CRGO is on the topmost, while silicon is the the second on the second rank. Now if we compare various material, most commonly used magnetic material in the all the electrical machine is silicon steel, and this is the reason why it is also known as electrical steel. Now there are features of the silicon steel. Firstly, that silicon steel belongs to ferromagnetic material. Now this ferromagnetic material is the we can consider like it is having a highest quality in terms of magnetic material. So that's why silicon steel is having the greater importance. Now it offers two unique quality which is really important from magnetic circuit design point of view. One is a low reluctance and high permeability. So those are the two unique feature. Now what is reluctance? So in the electrical circuit there is a resistance, and in the magnetic circuit there will be a reluctance S. Okay, now as you know that in order to, like, if for the current, now if resistance is more then less current will flow. Now in the magnetic material, if reluctance is more then less flux will be produced, so it will be given as Ni over S. Now if we have higher permeability and low reluctance, so low reluctance means higher flux, let's say reluctance is low, then higher flux can be established into the core. The third benefit, like, it has low hysteresis coefficients. So in the BH curve, we'll discuss later on that if in the BH curve, if this particular BH cycle, BH loop is having a very narrow area, then it will be having a lower losses. Now hysteresis loss can be given by this formula, eta. Now here in silicon steel, SS is 1.6, so which is lowest you can consider. Like if Bmax will be having lowest impact on this hysteresis loss. Let's say if this X is higher, then it can lead us to larger hysteresis loss. Now silicon steel is having mainly two materials, like one is a silica and other is a steel. Now you might be having question that why people are not using only steel. Okay, so steel of course has two things. One is a high uh, you know high permeability. Okay, so it allows more flux to pass through it, but at the same time it has a high conductivity also. So let's say if we use only this core material like this, which is of which is of steel only, then due to flux linkage there will be more current, which is also known as a eddy current. Now in order to reduce this current flow, we may have two possible solutions. One is we can add a silica. If we add silica in a steel, then what we'll be having is it will this silicon steel will be having a low conductivity. So ultimately this silica will add some resistance portion, and so it will control this eddy current magnitude, and that's why eddy current losses. So in the real while they make a silicon steel, they used to add 5% of silica. Now other possible ways is to having a laminations. So while you will be having a laminations in the core, so eddy current will flow like this, okay, through the laminations. So it will have a very small very thin path through which the current will be passed. So it will ultimately limit. Now silicon steel will be having a crystalline structure, so where there will be 8 atoms will be at the each corner of the crystal, and one atom will be at center. This, if you look at this particular length and this particular, like let's say this is a square, and if you look at this length, let's say this is L and L, so it will be square root of 2L. Now in the magnetic material, if crystal is replaced randomly, then this flux has to pass through this bigger length, and as you know that this reluctance can be given as length upon mu times area. If length of the magnetic path increases, then reluctance also will increase. So this is the one of the drawback of any silicon steel material, Like in the silicon steel material, uh, like as shown in this figure, those crystal will be placed very randomly. Okay, so sometimes the flux has to pass through its length, and sometimes through uh, square root of 2 times of length. Okay, like this. Now what, in order to make those grains or crystal in one direction, there is some heating process is there on silicon steel, just to orient those crystal in one direction. So that's why this process is known as a cold rolled grain oriented silicon steel. So in that particular material, all the silicon crystal are oriented in one direction. So that the magnetic flux will have to pass through this length only, and that's why reluctance S, which is equal to length upon area into permeability, will reduce actually. So this is all from my side. Thank you very much.